Welcome to another video on my Raspberry Pi 2 running Ubuntu Linux with the robot operating system connected to a serial cable for Minicom serial terminal, HDMI cable which isn't really functional right now. Then hidden is a network cable for the VNC and a bent cable which leads to a breadboard with some electronics and fischertechnik electronics, ordinary and fischertechnik. The objective is to let every item run a separate node. ROS, robot operating system, works with nodes, so a motor is a node, LED is a node, a phototransistor is a node, a button is a node, and they all run apart from each other, either giving information or getting information by subscribing. Last time I managed to get a third node running, so now I am only using this one, adding this LED, which worked. Now the idea is to get either the button working or this phototransistor working, because controlling something is one thing, getting information and sending it is another. So how will that work out? Not quite sure, but it's a try. And last time I was very happy that I actually managed to get the LED working. So let's go to the software and see how things work out. So with the software, on this computer, two VNCs, desktop 1 control source, motor source and LED source, LED from this LED. Control is the publisher, because in the robot operating system you have a node that is publishing and a node, well, corrector said one or more nodes that are publishing, and one or more nodes that are subscribing to the published message. It is about messaging. The motor gets controlled, and that is this motor. Then this LED works, so let's see that that happens. In the second VNC I have started ROS core, very necessary for ROS to run anyway. Control, and then let's start the LED, and then it is very nice if it is actually connected, and for the motor it is nice to be actually connected as well. So that would be or should be that one. Let's see. I should actually be taking other kind of wires that stick where they are. Anyway, LED is working. So now for the motor, that is working as well. So that is very nice. Oh, by the way, in this Minicom terminal, which is indeed the other end of the earlier pointed out serial connection on the Raspberry Pi, I have 4. So this is 1, that is 2. 3 is not used right now. 4 is now on the Mac, which I'm going to use because I want to write an other node which reads from this phototransistor, and in order to read and do something with it, I need to publish it. So I think that may be going another publisher, or transforming this one to be that. How I'm going to do that, I'm not quite sure. But let's first create another node and then see whatever happens. So for that, let's go to the Mac where I have prepared some more stuff. Right, so on the Mac, as you can see, a view from the same camera. Desktop is different though. Well, yeah, a little different, just one desktop. Number 4, as you can see. And I'm here inside the source directory, where I have control, motor and red LED. First of all, I am going to copy one of those files, and it's the fischertechnik thing that I'm going to use actually, not red LED. So copy ft motor to ft phototransistor.cpp. Yes, I'm entering the code. That's better, underscore. And now the question is what to do. First of all, which exactly is which? And I know by now that because I copied it from motor, this is 4, and looking here, phototransistor is going to, I think, pin 20. And now comes another thing that I have to look at the schematics, which I have to bring forward on the other computer. Because I need to be sure which is which, if I'm absolutely right. And it turns out that the fischertechnik phototransistor looks like not in place. Oh yes, it is in place, and it is running through pin 13. That is not likely. So, looking at the camera, this wire is going here, and then here it should be pin 13, which I doubt. So that would mean the schematics are wrong now. 6, 12, 14, 16, 18, 20, 22. That should be 22. pin 22. But that is strange. Pin 22. Oh wait, I'm doing wrong. That is indeed to the LED, so that is correct. So where is this wire going? That is pin 13. It is. And pin 13 is pin mode 2. So in here now comes the editing. This is then FT phototransistor. Let's first make this right. This should be pin 2. This as well. Subscribe. I'm fine with that. And that for now is it. So save into phototransistor. Now comes something else. I have to make a difference here in CMake list.txt. Enlarging this, going all the way to the end. That's better. I have nothing to change here, but I do have something to change right in the end. And let's enlarge this one as well, because it's only 3 lines that I have to copy. And then paste, empty space in. So this is going to be the name FT phototransistor. And then I have to change all this as well. So yes, that takes a little bit of time. And then running it. Okay, so now it helps that I have actually made a source code that already did everything without a ROS. So in the CMake list text I have here added a phototransistor. Copying, pasting saves a lot of time. And let me save it again to be sure. Then using this part from the LED test, LED etc. CPP test, and let me show you. Well, that is actually this part, but from this file. So if you have seen this series of videos before, or the former episodes, then you have seen no, it was actually in a different series where I was working without ROS, but trying to get things working from the GPIO with this library. And upon success I continued with ROS. That's the point. Anyway, I am using this part of the code. I changed this text now so it reads actually more or less the same, apart from the fact that I disabled the motor. So there's no motor again, which also means, by the way, that I have to delete this line. Right. Now I have to use catkin make to compile everything. And then I do realize I have to do that in a new window. So let me source first again. right? And now is a good question, because do I have to stop everything? I'm not quite sure, because the other roads are still running, as you can see here. This is running, the motor is running, so everything is still going on. Let me quit it. So first LED, motor and control. Which reminds me of the fact that these don't quit just like that. So I have to find them. Red LED. No, this one. This red LED, is it? I thought so. Red minus I, red. Right, that is 6304. Does that work? No such process. Okay. Oh, 8. Wait, 8. No such process. It's still running. I can barely read this. 06904. I thought I had good eyes, but 6904. Now it will stop. Yep. Then something with motor. And that is 6929. And that's correct. So now all I have to do is catkin, make, go. Hopefully everything is being done, and that means that I can then do phototransistor if it works out. Generating done, fine. I only need it to finish without an error or warning. Then shine a light on the phototransistor and everything should work nicely. That is, after all, the idea. Will it happen or not? That's the big question. It happens. So, out of the way for now. Now I should have, yes, I do have. That means that now I have to start everything all over again on the other computer. Because this needs to blink, this needs to run. So let's go. Start control. Start LED. Start motor. And how nice would it be if this one indeed runs. Yeah, now it is alive again. So let's run this phototransistor. And now the question is, does it do what I like? Red LED, where is that coming from? I am running the phototransistor. And this says motor. I'm not quite sure where I went wrong, but this is not what I intended. Not at all. I heard. What did I hear? Well, let me change this into... Oh wait, yes, I know what I did wrong. Oopsie. Let me cancel this one. This I need to change, copy, paste. And now I need to build it again. Oops. So first I need to cancel everything again. Yep, shutdown was requested by double stuff. So let me do that off screen. Well, I solved a few problems, one in the settings and one in the program itself. Because if you want to put things on screen, you have to use the library. So that is working. Then I will start red LED again, and I will start the motor again. And you can see now that the camera is a little bit delayed, but what is supposed to happen is that when the digital read is 1, then this should be printed as well. This is the phototransistor. So let's see if that is going to happen actually. And yes. Okay, let me had actually a live image. Alright, that yeah, now it works kind of. So for a smooth image I will revert back to the other PC, which has no delay in video, because this is too much delay. But this is working. I get a very nice difference in responding. And this means that I actually do have 3 separate nodes running. So the control node, motor node, red LED node, and the phototransistor node. So that is very good. Remains of course now the question, why didn't it work at first? Why did I get all those errors? And I can't say, because I don't know. I'm very glad this works now. It could be that there is something that I'm now doing correct within the CMake list file, because that is where it depends on, apart from correct working node with libraries, etc. So once again, when I shine upon here, it shows on the Mac screen immediately. Yep, and that is very nice. You can't see it now, I can, but you did see it earlier. So where to go from here? Well, the point is that earlier, as you could see, I activated the motor when shining a light on this one. And that is what I'm going to do next. Making here a subscriber so that there's a message being sent that the motor picks up and goes. And that is then nodes are sending from each other, and I have a second publisher. If because now the phototransistor node is a subscriber, can I have a subscriber within a publisher? Or a publisher within a subscriber? Nice question. And yes, I'm going to put that in the next episode. Very curious about that one. And with this experiment, I wrap this video with some nice new stuff, being well, this responding nicely, which I already knew because of the earlier file that I wrote without using ROS. So that's the next step, like I said. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. You can also follow me via Instagram and Twitter. And please show your support by making a donation via either PayPal or Wired. And you can also become a patron and may have your name mentioned depending on the pledge you make. And your name will be mentioned on my website, and depending on the pledge, also with my videos. This is going to be continued. Have a nice day. Don't forget, all information is also under this video, including the URL of my website. And bye bye.